This is module 4 study guide for lines and angles. Number 1, using the figure below, find the angle pairs for each postulate or theorem. In this figure, lines M and L are parallel. Part A says use the corresponding angles theorem. So, because lines M and N are parallel, we can use the corresponding angles theorem, which states that angle 1 is going to correspond to angle 5, and those two angles will be congruent. Angle 2 corresponds to angle 6, so those two will be congruent. 3 corresponds to 7, and 4 will correspond to 8. So because the lines are parallel, the theorem says that these corresponding angles will be congruent to each other. Part B, using the alternate interior angles theorem, again because M and N are parallel, alternate interior angles theorem states that alternate interior angles will also be congruent to each other. So 4 and 6 are alternate interior, so angle 4 will be congruent to angle 6, and 3 and 5 are also alternate interior angles, so angle 3 will also be congruent to angle 5. Part C, using the same side interior angles postulate. This is also known as consecutive, it just means same side. Because M and N are parallel, and using the same side interior angles postulate, we know that same side interior angles are supplementary. So when I add angle 4 and angle 5 together, they're supplementary, which means they add up to equal 180 degrees. Likewise, 3 and 6 are also same side interior angles. So when I add those two angles together, they're also supplementary. Last on part D, using alternate exterior angles theorem. Again, because M and N are parallel, alternate exterior angles theorem states that alternate exterior angles are congruent. So angle 1 is an alternate exterior angle with angle 7. So those two angles will be congruent to each other, and then 2 will be congruent to angle 8. So number 2, in the diagram above, so we're still looking at these two parallel lines cut by a transversal. If angle 5 measures 62 degrees, what other angles measure 62 degrees and why? So I'm looking at all the angles that will be congruent to angle 5. So from the first exercise, we saw that angle 1 is congruent to angle 5. And the reason for that was because they were corresponding angles. So corresponding angles. And 5 and 3 were also congruent to each other by alternate interior angles. So we're going to say angle 3 by alternate interior angles. And angle 5 is also congruent to angle 7, but this is because of vertical angles. So if you guys remember, vertical angles are angles that are opposites of each other. So 5 and 7 are opposite angles. So vertical angles are congruent. So angle 7 will also be congruent to angle 5. Number 3, if angle 3 equals 75 degrees, what does angle 6 measure and why? So if I look at my two parallel lines cut by a transversal up here, 3 and 6 are same side interior angles. And I know from part C that angle 3 and angle 6 added together equals 180 degrees. So by same side interior angle theorem, I know that angle 3 plus angle 6 equals 180, and since angle 3 is 75, 75 plus angle 6 will equal 180. Subtract 75 degrees from each side, so angle 6 equals 105. So that's the measure of angle 6. Number 4, we have vertical angles here. So whenever you see this kind of X pattern, it's forming vertical angles. So 2 and 4 are vertical angles because those are opposite, and 1 and 3 are vertical angles because those are opposite of each other. So I understand that the measure of angle 1 is equal to the measure of angle 2 by vertical angles. Vertical angles theorem, to be more specific. So in this diagram, they're telling me that angle 1 and angle 3 added together equal 180. But I have an understanding that 1 and angle 3 are equal to each other. 1 and 3 are equal to each other, so if I just do a substitution here of angle 3, I can say, and I'll sketch this on the side, the measure of angle 1 plus, I'm going to replace the measure of angle 3, since I know it's equal to the measure of angle 1 by vertical angles. Added together is going to equal 180 degrees. So I end up having 2 of these. 2 measure of angle 1 ends up being equal to 180. Divide by 2 to both sides to figure out what that angle is. 180 divided by 2 is 90 degrees. So if angle 1 is 90 degrees, I know angle 1 and angle 3 are equal to each other, so the measure of angle 3 is also 90 degrees. Which statement must be true and why? Well, angle 1 and angle 3 are vertical angles. Because of this statement, I know that they create 90-degree angles. That means L and M are perpendicular to each other. So I'd say A, and here's my reasoning why. So number 5 on the back side, based on the following figure, answer the following questions. We have this image here, we have a lot going on. They're asking us to find the value of x. So I need to find some kind of relationship between all the information I have here to find something that will help me figure out what x equals. So since vertical angles are very fresh, I see this x pattern and I can recognize where my vertical angles are. I know that vertical angles are congruent. Vertical angles are congruent. So my vertical angles here are going to be this 2x plus 4 and then this 6x minus 16. So since vertical angles are congruent, these two are going to be equal to each other. And this will help me find the value of x. So I'm going to subtract 2x from both sides. 4x minus 16 equals 4. Add 16 to both sides. This gives us 4x equals 20. Divide by 4. X equals 5. With this information now, we can find the measure of angle KPE. So on my picture here, KPE forms one of my vertical angles. So since we know what x is, we can plug it in and figure out what that actual angle is. So KPE equals 2x plus 4, and x is 5, so we're just going to plug in 5. So we end up with 10 plus 4, which is 14 degrees. So angle KPE is 14 degrees. Number 6, the two lines are parallel to each other. They're referring to these two lines. You can think about this as M and N. So, looking back, we can recognize that we have alternate exterior angles. These two angles are on the exterior, and we know that they're congruent to each other. So by alternate exterior angles being congruent, that 7x minus 2 equals 103 degrees. So now I can solve for the value of x, and we used alternate exterior angles to solve for it. So we add 2 to both sides, 7x equals 105. And then divide this by 7. So x will then equal 15. Now number 7, based on the figure below, state whether the conditions are true or false. So C and F are complementary angles, so the lines G and T are parallel. So I know that complementary means that that has to add to 90 degrees. So C and F cannot be complementary. If they're parallel, that means that C and F are equal to each other by alternate interior angles, so this would actually be false. Part B, since D and F are supplementary, lines G and T are parallel to each other. So D and F are supplementary, which means they add up to 180. So D and F are same side interior angles. Those do have to be supplementary in order for G and T to be parallel, so this will be true. C, angles D and E are supplementary. When we add D and E together, these are alternate interior angles. So if G and T are parallel, these actually have to be congruent and not supplementary. So we'll say false here. Part D, lines G and T are parallel because C and F are congruent. C and F are alternate interior angles, and if G and T are congruent, then those do have to be equal to each other, so that's true. True. Okay, number 8 on the back side. The diagram below shows us that point T is on line segment AB, and points R and S are on the perpendicular bisector of AB. Perpendicular bisector. So if we understand what perpendicular bisector means, perpendicular means it's forming a 90-degree angle, and bisector means that it's cutting into two equal segments. Bisector. So what this highlighted pink line is doing is cutting these two segments into two equal parts. So you can see that this portion here is 7, and the right side is 3 plus 4, which is also 7. So that is true. They want us to find the length of RA. So RA ends up creating this triangle up here. And I know that this is a 90-degree angle because it's perpendicular bisector. So what I have here is a right triangle with two of my legs being 7 and 6, and I'm looking for that hypotenuse. So in order to find RA, we need to use Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, and a and b are going to be 6 and 7, my legs, to find RA. So I'm going to set this up as 7 squared plus 6 squared equals RA squared, since that's what I'm looking for. So 49 plus 36 equals RA squared, or C, if you want to leave it as C. When we add these together, we end up with 81 RA squared. But I don't want RA squared, I want just RA. So in order to get rid of that square, we need to take the square root of both sides. So 9 equals RA. So this would be 9. RB, for the next one, ends up giving us something very similar. RB is also a right triangle with one of the legs being 6 and the other leg being 3 plus 4, which is 7. So, by the perpendicular bisector theorem, we know that RA is equal to RB. So 9 is also going to equal RB. So this will also be 9. TR is this triangle here. This is still a right triangle. One of my legs is 6, but now the other is 3. So in order to find what my hypotenuse is here, in this case it's TR, I still need to use Pythagorean theorem again. So we're going to say 6 squared plus 3 squared is going to equal TR. Quantity squared, we'll have 36 plus 9 equals TR squared. This adds up to 45 TR squared. And in order to just find TR, I need to take the square root of both sides. So I'm going to take the square root. I know that 45 is 9 times 5 TR, and I'm splitting it up so I can simplify the radical. So square root of 9 is 3, so I end up with 3 radical 5 is TR. And this is my exact answer, so I'm just going to leave it as that. 3 radical 5. TS creates this triangle down here. This is still a 90-degree angle. Now I have a smaller triangle with 2 of my legs being 3. So to find TS, I'm going to have 3 squared plus 3 squared is going to equal my hypotenuse. In this case, it's TS. So I'm going to have 9 plus 9 equals TS squared. 9 plus 9 is 18 equals TS squared. And I know that 18 is 9 times 2. So 9 times 2 equals TS squared. And if I take the square root of both sides, I'm going to take the square root of each of those parts to simplify my radical. Square root of 9 is 3. Radical 2 is TS. So this is my exact answer if you want to type that into a calculator to figure out what that is as a decimal. That's fine. AS creates the segment here, where one of my legs is 7 and the other is 3. I don't think I've done that combination yet. Let me do that up here. So AS gives us 7 squared plus 3 squared equals AS squared. 49 plus 9 equals AS squared. This gives me 58 equals AS squared. And I'm going to take the square root of both sides. So 58 isn't as nice. What perfect square for 58 would be? Let's see if I could divide this by 2 to see if I end up with a prime number. So we'll have 2, 18, yeah, I end up with 29. So I end up with 2 times 29. So I'm just going to leave it as radical 58 because that's as simple as I can write it. Radical 58 is AS. And then BS also has a leg of 7 and 3. So by perpendicular bisector theorem, I know that those are going to be equal to each other. So by perpendicular bisector theorem, I know that AS equals BS. So if AS is 58, BS will also be 58. Okay, this is number 8. The diagram below shows us that point T is on line segment AB, and the points R and S are on the perpendicular bisector of AB. So we need to understand what a perpendicular bisector is and what it does. So perpendicular bisector, perpendicular means it's at a 90-degree angle, and bisector means it's cutting it into 2 equal parts. So we have R and S on the perpendicular bisector. So this highlighted line here is my perpendicular bisector. And what it's doing is it's cutting this segment AB into 2 equal parts. So you guys can see that from A to the middle here it's 7. And then from the middle here it's 3 plus 4, which is also 7. So it is cutting it into 2 equal parts. So to find RA now, I'm looking for the distance between R and A here, that portion. But I know I have a perpendicular bisector. As you guys can see, this is a triangle. It's a right triangle with legs 6 and 7, and I'm looking for that RA. So what I can use to find it is Pythagorean theorem, which is a squared plus b squared equals c squared, where my legs are 6 and 7. So we're going to plug in 6 squared plus 7 squared equals RA squared, because that's my C. Opposite the 90-degree angle is your C value. And I'm just going to call it RA, because that's what we're looking for. So then we have 36 plus 49 equals RA squared. This becomes 49 plus 36. This becomes 85 equals RA squared. To get rid of a square, we need to take a square root, so we square root both sides, and this becomes the square root of 85, or a. So this can't be broken down anymore. I think it ends up being 5 times 17. So this is our answer here. Our exact answer is square root of 85. Square root of 85. Now they're asking me to find RB. And if you guys know what perpendicular bisector is doing, it's cutting it into 2 equal parts. Perpendicular bisector theorem says that these 2 orange lines will be the same distance. So, to find RB, we're going to say by perpendicular bisector theorem, I'm going to say RA equals RB. And RA is the square root of 85. So RB is also going to be the square root of 85. So that's RB right there. Now, I'm looking for TR. So TR is here from T to R. If you notice, that's a smaller triangle with my legs being 3 and 6 now, and I'm still looking for RT, which is the hypotenuse of that triangle. So, let me use a different color. Here we have 6 squared and 3 squared. To find that next one, let me do that here. 3 squared plus 6 squared equals, I'm going to call this TR squared. TR squared, again, I'm using Pythagorean theorem. A squared plus B squared equals C squared here. So we have 9 plus 36 equals TR squared. This becomes 45 TR squared. And then I need to take the square root of both sides to get TR by itself. So 45 I know is 9 times 5. So I can break this apart as the square root of 9 times 5 is TR. But the square root of 9 I know is 3. So my answer is going to be TR equals 3 radical 5 here. 3 radical 5. So this is my exact answer. And TS is down here. It's a different triangle, also a right triangle, and TS is also the hypotenuse there. So TS is a triangle with my legs being 3 and 3. So let's do that down here. So I have 3 squared plus 3 squared equals TS squared. And this gives us 9 plus 9, which is 18. 18 equals TS squared. So in order to find TS, I need to take the square root of both sides. And 18 I know is 9 times 2. 9 times 2 is TS. So here I know that the square root of 9 is 3. So my answer will be TS equals 3 radical 2. This is going to be my exact answer. Now, they're asking us to find AS. Okay, I'm going to use blue here. AS is this segment here. Perpendicular bisector makes that a 90-degree angle. And my legs now are 7 and 3. So I have 7 squared plus 3 squared equals AS squared. This gives us 49 plus 9 is AS squared. This gives me 58. And to get AS by itself, I need to take the square root of both sides. AS. So 58 ends up being like 2 times 29, which 29 is a prime number, so we can just leave it as square root of 58. This is our answer here. Square root 58. And the last one, BS. BS is also, I'm going to make that blue as well because one of the legs is 3 and the other is 3 plus 4, which is the one we just did. By the perpendicular bisector theorem, I know that AS and BS are equal to each other. So I'm going to say by perpendicular bisector theorem, I'm going to say that AS equals BS. So BS is radical 58 as well. Okay, number 9 now. Determine whether each pair of lines are parallel, perpendicular, or neither. Select the correct answer for each lettered part. So in order to figure out if these lines are parallel, perpendicular, or neither, I need to understand what it means to be parallel or perpendicular. So if two lines are parallel, that means they have the same slope. So I'm going to write that on there. If they are perpendicular, that means they have a slope that's the negative reciprocal. So we're going to say negative reciprocal slope. And if it's not the same and it's not the negative reciprocal, then it's going to be neither. So that's what we're going to do for all of these questions. We're going to check to see what the slopes are. And looking at those slopes, we'll be able to see if they're parallel, perpendicular, or neither. So on this first one, we have x minus 2y equals 12, y equals x plus 5. So this first equation is in standard form, and the second equation is in slope-intercept form. And this is the form that I want because I can see my slope very clearly there as the m value next to the x. So here, since there's nothing next to the x, my slope is 1. And here, this equation's in standard form, so I need to do a little bit of work to turn it into this form so that I can find what that m value is. So we'll do that here on the side. So we have x minus 2y equals 12. I'm going to subtract x from both sides. Negative 2y equals, I'm going to place the x value first, so this is a negative x plus a 12, because the 12 is positive. I'm going to divide by negative 2 to both sides. So this ends up giving me y equals negative, there's a 1 up here, 1/2 x, 12 divided by 2, I don't really care about because all I care about is the m value, but this is plus 6. So I'm looking at the slope of 1 and this 1/2. Clearly they're not parallel because they're not equal to each other, they're not the same, and they're not perpendicular because they're not the negative reciprocal of each other. So it's neither for that first one. For part B now, this equation is not in slope-intercept form, but this one is, y equals 5x. So my slope here is 5, and I need to do a little bit of work on this left side, standard form, to turn it into slope-intercept form to find that b value. So let me use a different color now so you guys can see. So I'm going to take my b here. Boop. 1/5 x plus y equals 8. I'm going to subtract this 1/5 x to both sides. 1/5 x. So this becomes y equals negative 1/5 x plus 8. Now if I'm looking at those slopes, I have 5, and then I have negative 1/5. So those are not the same, so they're not parallel, but they are negative reciprocals of each other. 5 I can write as 5/1, and the negative reciprocal of 5/1 would be negative 1/5. So these are perpendicular. The next one, C, this is in standard form, and this isn't in standard, but it's close to slope-intercept form. We just need to divide by 3 to both sides here. So if I divide by 3 to both sides, I'll end up with a slope of negative 2 over 3 here. Let me write that here. Negative 2 over 3. So I'm going to use that information, apply it here to see if they're the same. So I need to find the slope of this line. So I'm going to take this equation, 3x minus 2y equals 12, and I'm going to solve for y now. So I'm going to subtract 3x from both sides, negative 2y equals negative 3x plus 12, and divide negative 2 to both sides. We end up with y equals a negative divided by a negative is a positive. So this is 3/2 x. I don't really care about the y-intercept, but just for giggles there, it's minus 6. So my slope here, negative 2 over 3. Slope here is positive 3 over 2. So they're not parallel because they're not equal to each other, but they are perpendicular because they're negative reciprocals of one another. So they are perpendicular. Check. Part D now. My first equation, y equals 3x minus 1. That one is in slope-intercept form, so my slope there is 3. My second equation there, 15x minus 5y equals 10, is not in slope-intercept form, so I want to change that so I can find my m value. So we'll have 15x minus 5y equals 10. Subtract 15x from both sides. We end up with negative 5y equals negative 15x plus 10. And then we're going to divide by negative 5 to both sides, so this becomes y. Negative 15 divided by negative 5 is a positive 3x. And here we have a positive divided by a negative. 10 divided by 5 is 2. Okay. So here we have a slope of 3, and here's another slope of 3. Those are the same, so because they're the same, they are parallel. Last one, here we have 7y equals 4x plus 1. That's almost into slope-intercept form. We need to divide by 7. If I divide by 7 here, boom, boom, y equals 4 over 7. X plus 1/7. So my slope here is 4 over 7. What color haven't I used? I'll use pink again. 4 over 7 is the slope I'm looking at. Now I'm going to look at that right equation to see what that gives us, to see if it's parallel, perpendicular, or neither. So we have 14x plus 8y equals 10. Subtract 14x from both sides. This becomes 8y equals negative 14x plus 10. Divide 8 from both sides. So I get negative 14 divided by 8x plus 10 divided by 8. So 14 divided by 8, I can simplify that fraction by dividing by 2 to top and bottom. So I'm just going to write the slope here. I'm going to get negative 7 divided by 4. Looking at the slope I'm trying to compare it to see if it's parallel, perpendicular, or neither. It's not parallel because they're not the same, but they are perpendicular because they're negative reciprocals of one another. So they are perpendicular. Okay, so number 10, which of the following equations is perpendicular to the line y equals negative 3 over 4x plus 4 and passes through the point 12, negative 5. So perpendicular means I want to use the negative reciprocal as my slope. And my slope here for this line is m equals negative 3 over 4. So my perpendicular slope is going to be the negative reciprocal. So my new slope is going to be positive 4 divided by 3. And I want it to pass through this point 12, negative 5. So I need to use point slope form. Y minus y1 equals m times x minus x1. We're going to plug in 4 over 3 for our slope and then 12, negative 5 for our point. So 12, negative 5. 12 will be my x1, negative 5 will be my y1. So then we have y minus a negative 5 equals 4 over 3 times x minus 12. When we subtract a negative number, it turns into a positive, and then this becomes 4/3 times x, which is 4 over 3x. And then here we can do 4 times 12, which is 48. 48 divided by 3 is 16, so minus 16. And we're going to subtract 5 from both sides, so then this turns into y equals 4 over 3x minus 21. So then that one would match with B. Okay, so for here 11, given the points 2, negative 7 and 12, negative 13, determine whether the lines contain those points are parallel or perpendicular to negative 10, 6 and negative 5, 3. In order to figure out if they're parallel or perpendicular, parallel is going to have the same slope, and perpendicular is going to have the opposite or negative reciprocal. Negative reciprocal. So what we're going to want to use here is kind of a version of point slope. So rise over run, x2 minus x1. So we have 4 points total. We're going to use the first set of points first. 2, negative 7, and then 12, negative 13. So x1, y1, x2, y2. And then we're going to plug it in, see what we get. So we're going to get m equals negative 13 minus a negative 7 over 12 minus 2. So then this gives us, minus a negative is adding a positive. This gives us negative 6 divided by 10. And this gives us 3 over 5 if I divide by 2 to top and bottom. So now I'm going to compare this slope to the other one. I need to find the slope of the other one. So now we have negative 10, 6, and negative 5, 3. So this is x1, y1, x2, y2. Plug it in. We get 3 minus 6 divided by negative 5 minus a negative 10. So this gives us negative 3 over 5. So because the slope is the same, they are parallel. Okay, so given the points 12, 10, and 13, 15, determine whether the lines that contain those points are parallel or perpendicular to 9, 1, and 4, 2. So we're going to do the same thing here. We're using this equation here to find what our slope is. So let me just label 12, 10, and 13, 15. We're going to label this x1, y1, x2, y2, and we're going to plug in to see what the slope would be. So 15 minus 10 divided by 13 minus 12. 15 minus 10 is 5, so we get 5 over 1 here. That's my slope. And I'm going to compare it to 9, 1, and 4, 2. So this is x1, y1, x2, y2, plug in. So 2 minus 1 divided by 4 minus 9. This gives us negative 1 divided by negative 5. So a negative divided by a negative is a positive, right? Oh, this is a positive one. 2 minus 1 is a positive 1. So we end up with negative 1/5. And those are not the same slope, but they are negative reciprocals of each other. 5 over 1, taking the reciprocal is 1 over 5, and then we take its opposite. So this one would be perpendicular. Okay, given the equations 3x minus 5y equals 10 and 10x plus 6y equals 40, determine whether the lines are parallel or perpendicular to each other. So these two equations are in standard form. They're not in slope-intercept form. What we're going to want to do is change them to slope-intercept form. so we can see what the slope is. So we're going to subtract 3x from both sides. So we end up with negative 3x plus 10, and we're going to divide by negative 5 to both sides. So we end up with y equals a negative divided by a negative gives me a positive 3 over 5. 10 divided by negative 5 is minus 2. So this is the equation, and what I care about here is that slope 3 over 5. So now I'm going to do the same thing to the other equation. 10x plus 6y equals 40. Subtract 10x from both sides. 6y equals minus 10x plus 40. Divide by 6. We end up with y equals negative 10 over 6x. And then 40 divided by 6, I don't really care. All I care about is that slope. But I can simplify this slope a little further. This ends up being negative 5 over 3x plus whatever this is. So looking at these two, all I care about is the slope. That's what I'm looking at. They are not parallel because they're not the same, but they're perpendicular because they're negative reciprocals of each other. So 3 over 5, its opposite reciprocal, negative reciprocal, is a negative 5 over 3. So these are perpendicular. Okay, so number 14, given the equation 6x plus 2y equals 15 and 3x plus y equals 36, determine whether the lines are parallel or perpendicular to each other. So remember, the lines are parallel if we end up with the same slope, and they're perpendicular if their slopes are negative or opposite reciprocals. Opposite reciprocals of each other. So let's start off with 6x plus 2y equals 15. I want to rewrite this into slope-intercept form so I can see what that m value is going to be, that slope. So I'm going to subtract 6x from both sides. We end up with 2y equals minus 6x plus 15. Divide by 2 to both sides, so then this becomes y equals negative 6 divided by 2 is negative 3x. And then I'm just going to leave this as 15 divided by 2, because all I care about is the slope. Don't forget, this is what we care about right here. So there's my slope, negative 3, and I want to see if this other equation equals 36 is either parallel, perpendicular, or neither to each other. I guess just parallel or perpendicular. So we're going to subtract 3x from both sides. So we end up with y equals negative 3x plus 36. And all I care about is that negative 3. Because they're the same, they are parallel and not perpendicular. Okay, so on this one we have use the figure to find angle measures in the figure. M and N are parallel, and X and Y are also parallel. So if angle 5 equals 70, then measure of angle 4 equals blank because, and we're going to give the reason why. So angle 5 is here on my picture. Now I'm trying to figure out what angle 4 is over here. So I'm going to rotate the picture. Zoom in a little. I'm going to rotate this picture so you can see my two parallel lines cut by a transversal. The 4 and the 5 are on the outside, the exterior. So alternate exterior angles theorem. The theorem says if those lines are parallel and M and N are parallel, then 4 and 5 are going to be congruent. So angle 4 is going to be congruent to angle 5. So if angle 5 is 70, angle 4 is also going to be 70. Thanks. It's okay, you could have told me. So then if angle 6 is 102, what would 12 be? so we are, it's hard to see, I'm just going to zoom in. So 12 and 6, I know that 12 and 7, angle 12 and angle 7 are alternate interior. Alternate interior angles. So angle 12 is congruent to angle 7. And then 7 and 6 are corresponding. So if I can figure out what angle 7 is, and I know that angle 6 and angle 7 are supplementary because they're same side interior. So angle 6 and angle 7 are same side interior, which means angle 6 plus angle 7 equals 180. So 102 plus something equals 180, and whatever that is what angle 12 is going to be. So 102 plus angle 7 equals 180. Subtract 102 from both sides. So angle 7 equals 78 degrees. So then that means angle 12 is also going to be, since they're the same, they're congruent, this is also going to be 78 degrees. Okay, so number 16, we have two lines cut by a transversal. Mark is asked to prove that angle 4 is congruent to angle 6. Given that AB and CD are parallel, so these are parallel. Mark's proof is shown in the table below. So angle 4 is congruent to angle 8. Therefore, angle 4 equals angle 8. Angle 4 is congruent to angle 6, therefore angle 8 is equal to angle 6. If angle 4 and measure of angle 8 and measure of angle 8 equals measure of angle 6, then angle 4 equals angle 6. That means that angle 4 and angle 6 are congruent. Which reason supports the statement Mark made in step 2 of his work? So this step. So, we're looking at 8 and 6 here. 8 and 6, one's on the interior, one's on the exterior, and they're not corresponding. But whenever you see this X shape, that means opposite angles are called vertical angles, and they're congruent. So, angle 8 and angle 6 are congruent, therefore they're equal. That's because they're vertical angles, and vertical angles are congruent. So number 17, the proof below shows that alternate interior angles are congruent when two parallel lines are cut by a transversal. Okay, so we have two lines cut by a transversal, and they're saying that alternate interior angles are congruent. So lines R and S are parallel lines cut by a transversal, that's given. Part 2 says angle 1 is congruent to angle 6. Angle 1 is congruent to angle 6. So 1 and 6 are congruent. So again, whenever you see that X shape, that's because of vertical angles. So we would say vertical angles theorem. Because 1 and 6, it doesn't matter if the two lines aren't even parallel. If we're trying to prove that, 1 and 6 will always be congruent to each other. And then part B, so angle 1 and angle 3, 1 and 3 are congruent. Well, angle 1 and angle 3 are corresponding. So they're corresponding angles. Corresponding angles are congruent. So we're going to say corresponding angles theorem. And if that's true, then we can say that angle 6 and angle 3 are congruent. Okay, here's the last one. Hank writes a proof to show that vertical angles are congruent. So this is what we're trying to show. We have this picture here, this diagram. Given lines M and N intersect at a point, prove that angle 1 and angle 2 are congruent. So I want to show that these two angles are congruent to each other. So let's go through their logic. Let me zoom in a little here. Lines M and N intersect at a point. That's the information that they gave me. And what I'm trying to prove is always my last statement. Angle 1 and angle 3 are linear pairs. Angle 2 and angle 3 are linear pairs. Yeah, because they create a line. 1 and 3 are linear pairs. 2 and 3 make a line. Definition of linear pair is to be supplementary. So angle 1 and angle 3 are supplementary angles. Angle 2 and angle 3 are supplementary angles, because that's what it means to be a linear pair. But what does this word supplementary mean? Supplementary means it adds up to 180 degrees when we add those two angles together. So in this line here, we're going to say angle 1 plus angle 3. Those measures equal 180, and angle 2, the measure, plus the measure of angle 3 also equal 180, because that's the definition of supplementary. Definition of supplementary angles, we're going to put right there. Supplementary angles, that's what it means. If they're supplementary, what does that mean? I can now write those equations. Now substitution means I'm replacing something. So from here I'm going to say the measure of angle 1 plus the measure of angle 3 equals, since they're both equal to 180, I'm going to say the measure of angle 2 plus the measure of angle 3. Those are equal to each other. And when we subtract the measure of angle 3 from both sides, we end up with this equation. And that makes those congruent.